Okay, we're going to look at question 2 on the homework assignment. This one, a data set about speed dating includes like ratings of male dates by the female dates. The summary statistics are given. They want us to use a significance of 0.10 to test the claim that the population mean is less than 6. So identify the null and alternative hypothesis, the test statistic, the p-value, and state the final conclusion. So on this one, the null hypothesis is that the mean is 6. We are testing that it's less than 6, so that is our alternative hypothesis. And then everything else on here comes from StatCrunch. So what I did over on StatCrunch is I went to stat, tstat, one sample with summary, and I put in the mean, the standard deviation, the sample size, my test of 6 and less than 6, and then I computed. You can see those results here. The t-stat is this negative 3.31. The p-value is 0.0006. The thing is, my math lab wants you to round that to 3 digits, so that's how you end up at 0.001. But we can reject the null hypothesis because we are below our 0.10 level on that p-value. We're way, way, way below it. There is sufficient evidence to conclude that the mean of the population ratings is less than 6. All right, the next one we're going to look at is number 4. And if you click this button, you can open it in StatCrunch with the data. And so I'm going to do stat, tstat, one sample, with data. Data is in variable 1. We want to do a hypothesis test that mu is 16, and we want to do less than 16, and compute. You can see that we end up with a t-stat of negative 2.31 and a p-value of 0.023. On this problem, we wanted to a 0.10 significance level. We have 0.023, so again we can reject the null and conclude that the mean lead concentration of medicines is less than 16. I think that's micrograms, might be what that is. So that works. And again, the null hypothesis was that it equaled 16, and our alternative was that it was less than 16. Okay, the next one of these that we want to look at is question 14. Use the given data set to complete parts A through C below. Use alpha is 0.05. Now again, I think the nice thing, we can just pop this open in StatCrunch, and we can go to stat. We can go to calculators. Well, where is this? Oh, calculator, we can go to regression. Our x variable is x, our y variable is y, the way this loaded in. And I think we're just going to run it just like that. So first off, this thing actually gives us a plot, so we can compare that to the plots that we have here to choose the right one. So if you look, you can see that it is this linear one here, letter B, so that matches up really well to what we have. There's the one outlier that you see there, kind of outlier, not 100% sure that it's an outlier, but it looks like one. You can see the correlation coefficient is 0.18574817, which rounds to 0.816, which again they asked for that. And then using that linear correlation found in the previous step, determine whether there's sufficient evidence to support the claim of a linear correlation between the two variables. So for that one, we're going to need to look at the critical values. We're looking at alpha is 0.05. They gave us this table here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 ordered pairs. So we would need a value of 0.602 for 0.05 alpha. We got above that, we got 0.816. So there is sufficient evidence to support the claim of a linear correlation between the variables. And then identify the feature of the data that would be missed if part B was completed without constructing the scatter plot. Well, the thing that we notice is that by looking at the scatter plot, we can see that there is this really, really perfect straight line, except there is one outlier. So that is what we get out of looking at the picture versus just getting the R value and saying that they're correlated. There could be a lot of pictures that would have that same correlation coefficient, but they might be like a little more scattered but close to the line. But here it's perfectly linear with just one out of place. So that's a little more knowledge we get by looking at the picture. The last one we're going to look at is number 15, and this one they've given us the results and we are interpreting them. 54 wild bears were anesthetized and their weights and chest sizes were measured and listed in the data set. Results are shown in the accompanying display. Is there sufficient evidence to support the claim that there's a linear correlation between the weight of the bears and the chest sizes? When measuring the bear, is it easier to measure the chest size than the weight? If so, does it appear that a measured chest size can be used to predict the weight? Use a significance level of alpha equals 0.05. So, first off, our null and alternative hypothesis on these is, so what we're looking for is there a linear correlation between these? So it didn't say positive or negative, so we're doing the two-tailed test here. So the null hypothesis is that there is no correlation, and the alternative is that there is, so that's not 0. The correlation coefficient you can see is the 0.964 given right there. There's two critical values, which makes sense because you're going two-tailed, so on either side there would be a critical value. And then is there sufficient evidence to support the claim that there's a linear correlation between the weights? I'm very, very certain that 0.964 is going to exceed our critical value. The way that I know is that this p-value of that is really, really, well, no. The way that we know is we got our R as 0.964 and our critical R's were 0.268. That's way, way above that. You also know because the p-value is basically 0, which is way below the alpha's 0.05, so we know this is all going to work. So when measuring the bear, is it easier to measure chest size than weight? And if so, does it appear that a measured chest size can be used to predict the weight? Yes, it definitely is. You don't have to lift a bear onto a scale. That's kind of a funny thing. And the chest size can be used to predict the weight because there is a linear correlation between the two. All right, I hope this is helpful. It is pretty nice being able to just click these data sets and load them right into StatCrunch and work from there. Like that really makes these just nice. You just have to click a couple buttons and stuff and then do some interpreting. So I hope this helps. Hope everybody's doing okay. I will see you in person next week. Hopefully we're going to talk about the final and wrapping up the class. One more section video coming on Tuesday.